Most people believe this happens because of age, but science tells a different story. It often begins quietly. A slight heaviness after meals, a number on a blood sugar monitor that seems just a little higher than expected, a sense that the body is no longer responding the way it once did. I've had many patients tell me in almost the same words, "I'm eating carefully, I'm doing everything right, so why does it still feel out of control?" And it's a very reasonable question, because what if the real issue isn't simply about sugar or even insulin? What if something far more basic, almost invisible, is shaping the entire picture? Research suggests that as we age, one of the most overlooked changes happens not in what we eat, but in how our cells interact with water. Not just drinking water, but something deeper: cellular hydration. Inside your body, trillions of cells are constantly making decisions, like tiny rooms deciding whether to let glucose enter. And insulin acts like a key, gently signaling those doors to open. But here's where it becomes fascinating. Scientists have observed that when cells are even slightly dehydrated, their outer membranes can become more rigid, almost like a door that has swollen shut in humidity, refusing to open smoothly. So even if insulin is present, even if everything else seems in place, the response may feel delayed, resistant, or unpredictable. Could it be that the body isn't ignoring insulin, but simply unable to respond efficiently? And if that's true, what else might be quietly influencing this process? Because this is where the story begins to deepen. Let's step a little closer inside the cell itself. Imagine for a moment a small living room within your body. Glucose, your body's primary fuel, waits outside, ready to enter. Insulin arrives like a gentle knock, signaling that it's time to open the door. And in younger years, this process feels almost effortless. The door opens, glucose flows in, energy is created. But over time, something subtle begins to change. Research indicates that the outer membrane of the cell, this delicate, intelligent barrier, can lose a bit of its flexibility. Not dramatically, not all at once, but gradually, like a well-used hinge becoming stiff. And here's the intriguing part. Water plays a quiet but essential role in keeping that membrane soft, responsive, almost alive in its movement. Without adequate hydration inside the cell, the membrane may behave less like a fluid gateway and more like a rigid wall, almost as if the key is still working, but the lock itself has become resistant. Studies suggest this reduced fluidity can influence insulin sensitivity, making it harder for glucose to enter efficiently. Not because the body has failed, but because the environment inside the cell has changed. Have you ever noticed how a dry sponge struggles to absorb water at first, until it slowly softens again? The cell, in many ways, behaves similarly. So the question becomes, if the problem isn't just insulin or sugar, but the condition of the door itself, what might restore that softness, that responsiveness? Because what scientists have observed next begins to challenge something many people rely on every day. Now, here is where things become quietly surprising. Most people trust thirst. It feels intuitive, almost automatic. You feel dry, you reach for water. Simple. But after the age of 60, research suggests that this signal begins to change in a very subtle way. It weakens. Scientists have observed that the body's thirst mechanism, once sharp and reliable, becomes delayed, almost muted. By the time a person actually feels thirsty, the body may already be in a state of mild dehydration. Not severe, not dramatic, but persistent. And that persistence is what makes it so easy to overlook. Have you ever gone through a morning, perhaps reading or sitting near a window with soft sunlight, and suddenly realized hours have passed without a single sip of water? Nothing felt wrong, and yet something was quietly shifting inside. Studies indicate that even mild dehydration can influence blood viscosity, circulation, and cellular efficiency. In other words, the body begins to move a little slower, respond a little less precisely, like a river that still flows but with less ease, less calamity. And when this happens at the level of your cells, those tiny doors we spoke about earlier may not respond the way they once did. Not because they are broken, but because they are waiting for something they are no longer being signaled to receive. So if thirst is no longer a reliable guide, how does the body actually bring water into the places that matter most? Because this is where a lesser-known part of biology begins to reveal itself, something most people have never heard of. There is a tiny structure inside your cells that rarely gets mentioned, and yet it quietly controls the flow of life itself. They are called aquaporins. You can think of them as microscopic doorways, specialized channels that allow water to pass in and out of the cell with precision and timing, not randomly, but intelligently, based on the body's needs. In younger years, these channels respond quickly, almost like automatic sliding doors. Water arrives and the cell welcomes it. But research suggests that with age, aquaporin activity may become less responsive. Not completely shut down, just slower, less efficient, like doors that no longer open as easily when someone approaches. So even when a person drinks water, the real question becomes, is that water actually reaching the inside of the cell, or is it simply passing through the body without deeply nourishing it? This may help explain something many seniors notice: drinking more water, yet still feeling dry, fatigued, or out of balance. It's like watering a garden where the soil has hardened. The water runs across the surface, but very little sinks in. Scientists have observed that cellular hydration depends not just on intake, but on transport. And when transport slows, the effects ripple outward, touching metabolism, circulation, even how cells respond to insulin. So if the pathway itself has changed, what else might be quietly influencing how much water the body is actually able to retain? Because there is another factor, one many people encounter daily without realizing its hidden effect. I remember a patient once telling me, with a gentle smile, "I take my medications exactly as prescribed. I've been very careful." And that care matters deeply. But what many people are not always told is that some of the most commonly used medications, especially for blood pressure and blood sugar, can have a secondary effect that is easy to miss. They can increase fluid loss. Research indicates that certain medications act as diuretics, encouraging the body to release excess water through the kidneys. This can be helpful for specific conditions, but over time it may also contribute to a subtle, ongoing depletion. Not enough to feel alarming, but enough to matter. Have you ever noticed more frequent urination after starting a medication, or a slight dryness that didn't seem to have a clear cause? It's often dismissed. Yet inside the body, this creates a quiet imbalance, like a reservoir that is slowly draining even as you try to refill it. And when this happens alongside a weakened thirst signal and slower cellular transport, the effect can compound. Scientists have observed that hydration is not just about intake, but about retention and distribution. So even if someone is drinking enough, the body may still be operating at a deficit where it matters most. Which leads to an important question. If water alone isn't always enough, and the body is losing more than expected, what helps the body actually hold on to hydration and use it effectively? Because the answer introduces a missing piece most people never consider. Here is where the story takes an unexpected turn, because water on its own may not be the complete solution. Inside the body, many processes, especially those involving glucose transport, are not just chemical, they are electrical. Tiny signals carried across membranes guide nutrients into cells, and these signals depend on something very specific: minerals. Sodium, potassium, magnesium. Research suggests these elements help create the electrical gradients that allow water and glucose to move efficiently into the cell. Without them, water may lack the direction it needs, like a message without a signal to carry it. Have you ever tried charging a device with a loose cable, where the connection is there but unstable? That's what hydration without proper mineral balance can resemble. Water is present, but the transfer is inconsistent. Studies indicate that adding trace minerals to water may support cellular uptake by improving conductivity, not dramatically in a single moment, but gradually over time. And this is where a simple shift begins to emerge. Not just drinking more water, but drinking it in a way the body can actually use. So the question becomes, when is the body most receptive to this kind of hydration? Because timing, as it turns out, may be just as important as the water itself. And this is where the first window quietly opens. The body has rhythms. Gentle, predictable waves that rise and fall throughout the day, even when we're not aware of them. And one of the most important moments happens just after waking. Before breakfast, before movement, before the day fully begins. Research suggests that in the early morning, levels of cortisol, a natural hormone, are slightly elevated. This is part of the body's way of helping you wake up. But it can also be associated with a temporary rise in blood glucose, a kind of internal morning surge. Now imagine this. After hours of sleep, the body is slightly dehydrated. The bloodstream is more concentrated, the cells a bit less receptive, like a landscape waiting for its first rainfall. Studies indicate that gentle hydration upon waking, especially at room temperature, may help dilute this concentration and support smoother metabolic activity, not forcefully, but naturally. Have you ever noticed how the first sip of water in the morning feels almost unusually refreshing, as if the body has been quietly waiting for it? That response is not accidental, it's biological. And when this moment is used intentionally, it may set the tone for the hours that follow. So the question becomes, if the first sip can influence the morning, what happens when hydration is timed just before the body encounters food? Because this next window changes something many people assume is fixed. There's a moment before every meal that often passes unnoticed. A quiet pause when the body is preparing for what's about to come. Digestive enzymes begin to activate, blood flow subtly shifts, and the body anticipates the arrival of nutrients. But research suggests something else can happen in that window. Hydration about 30 minutes before eating may influence how the body processes glucose from that meal. Not by blocking it, but by guiding it. Imagine pouring water onto dry soil before planting seeds. The ground softens, becomes more receptive, more balanced. In a similar way, studies indicate that pre-meal hydration may help support digestion and slow the rapid absorption of carbohydrates, leading to a more gradual rise in blood sugar. Less of a spike, more of a steady curve. And then there are the hours in between. Mid-morning, mid-afternoon, times when energy quietly dips and many people reach for something sweet or stimulating. But what if that feeling isn't always hunger? What if sometimes it's the body asking for hydration? Scientists have observed that even mild dehydration can mimic fatigue and cravings. So a simple glass of water at the right moment may shift the entire pattern. But what about the final hours of the day, when the body begins to slow down? Because hydration doesn't stop when the sun sets. In fact, something important continues through the night. As evening settles in, the body begins a quiet transition. Heart rate slows, digestion winds down, and behind the scenes, a different kind of work begins. Repair, regulation, filtration. During sleep, the kidneys continue to process the blood, gently removing waste and maintaining balance. It's a delicate system, one that depends, in part, on having enough fluid available, but not too much at the wrong time. Research suggests that light hydration a couple of hours after the last meal may support this overnight process without disrupting sleep. Too little, and the system works under strain. Too much, too late, and the night becomes interrupted. Have you ever woken up feeling slightly dry, or noticed that your morning readings seem more unpredictable after an evening of inconsistent hydration? These small patterns often connect more than we realize. It's like setting the stage before a performance. The conditions you create in the evening shape what unfolds by morning. And temperature plays a role here too. Studies indicate that very cold water may cause temporary vasoconstriction, narrowing of blood vessels, which can slow absorption and subtly trigger stress responses. Whereas room temperature or warm water tends to be received more gently, more efficiently. So even something as simple as temperature begins to matter. But there are still a few hidden habits, ones that feel comforting, familiar, yet may quietly work against this entire process. And one of them is sitting in many cups every single day.
For many people, the day begins with it. A warm cup in the hands, a familiar aroma, a small ritual of comfort and clarity. Coffee or tea. And there's something deeply human about that moment. But here is where things become a little more complex. Research suggests that caffeinated beverages can have a mild diuretic effect, encouraging the body to release more fluid than it retains. Not dramatically in every case, but enough to influence overall hydration, especially when intake is already low. So the question becomes, is that morning cup adding to hydration or quietly subtracting from it? Some scientists have observed that balancing each caffeinated drink with additional water may help maintain equilibrium, not removing the ritual, but supporting the body alongside it. And then there is a second, less obvious factor: winter. Have you ever noticed that during colder months you feel less thirsty, even though indoor heating quietly dries the air? Studies indicate that this invisible dehydration can sometimes be more pronounced than summer, simply because it goes unnoticed. No sweat, no obvious signal, just a slow, steady loss, like moisture leaving the skin without a trace. So even when habits feel unchanged, the body's needs may have shifted. And when all of these small patterns, timing, minerals, temperature, daily habits begin to align, something remarkable starts to happen over time. Not instantly, but gradually. And this final piece of the story unfolds over weeks, not days. Change in the body rarely announces itself loudly. It unfolds quietly, in layers, over time. And hydration is no exception. Research suggests that when the body begins to receive consistent, structured hydration, supported by minerals, timing, and gentle rhythms, it doesn't transform overnight. Instead, it adapts. In the first week, many people notice something simple: more frequent urination. It can feel surprising at first, sometimes even inconvenient, but scientists have observed that this may reflect the body recalibrating, adjusting fluid balance, releasing what it no longer needs. By the second week, something more subtle may begin to emerge: smoother energy, fewer fluctuations. Some studies indicate that glucose variability may start to stabilize as the internal environment becomes more consistent. Have you ever felt a sense of steadiness where the highs and lows begin to soften? Then, by the third week, early changes in fasting patterns may appear. Not dramatic, but noticeable. Like watching the tide slowly shift along a shoreline. And by around 3 months, the lifespan of red blood cells, research suggests that longer-term markers, such as A1C, may begin to reflect these internal changes, not because of a single action, but because the environment those cells lived in has changed. More hydrated, more balanced. So perhaps the question isn't just how much water we drink, but how we allow it to move, to support, to restore. Because sometimes the smallest, quietest shifts are the ones that change everything.